Hello everyone, welcome back to the channel Simple Science. Today we'll study about superconductors and Meissner effect. So remember the basic classification of materials, that is in conductors, insulators and semiconductors. Now this classification told us about the property of materials, especially the ability to conduct electricity. It is done based on the difference between the conduction band and valence band, or to say based on the energy band gap. But that was different from this term, that is superconductor. So what exactly is superconductor? Now the answer is superconductors or superconducting materials are metals, ceramics, organic materials or heavily doped semiconductors that conduct electricity without any resistance. Let's look at some of the properties of superconductor. First, they conduct current perfectly. Due to resistance value 0, the current carrying capacity increases. Second property is it is observed at critical temperature, that is Tc. Now, superconductivity occurs at a specific material's critical temperature denoted by Tc. As the temperature decreases, a superconducting material resistance gradually decreases until it reaches critical temperature. So for this, let's observe the graph. As you can see in the graph, there are two curves. First curve is for non-superconductor, or you can say for normal materials. In that case, as you decrease the temperature, the resistance value also decreases. It does decreases with the temperature, but the resistance value does not correspond to 0 in case of non-superconductors. Whereas now look at the second curve, that is the curve showing superconductor. In this case, as you decrease the temperature, the resistance decreases, but it reaches a critical temperature. As it reaches a critical temperature, the resistance drops to 0, and this point is called as the superconducting point and is denoted by C, that is the critical temperature. From here onwards, the conductivity occurs at 0 resistance, and thus it is called as superconductor. The third property is no power loss. As the formula of power is P is equal to I square R, the resistance value is 0, so the power loss will be 0 in case of superconductors. The fourth property is it expels magnetic field during transition to superconducting state. This property leads us to the Meissner effect. The superconducting material sets up an electric current near their surface at Tc, therefore cancelling the field within the material itself. A stationary magnet on a superconductor demonstrates this effect. As the superconductor cools through its critical temperature, the expulsion of magnetic flux from the conductor causes the magnet to levitate above the material. No amount of magnetic field can pass through the material at this state. So this is what is the Meissner effect. Now the condition for Meissner effect to occur is, first, if the external magnetic field may be made so strong that it prevents a transition to the superconducting state, then Meissner effect does not occur. That is, the strength of the magnetic field is not allowing the material to go into the superconducting state, and if it is not going in the superconducting state, then Meissner effect will not occur. The second scenario is intermediate magnetic field strength, which are present during the cooling, produces a partial Meissner effect, as the original field is reduced within the material but not wholly expelled. In this case, the magnetic field are not wholly expelled, and thus only partial Meissner effect is observed. Now the third and final state is a superconductor with little or no magnetic field within it is said to be in the Meissner state. So the only thing that you need to remember is that in Meissner state, no amount of magnetic field will pass through your sample, and this is what is Meissner effect all about. Thank you so much for watching.